Hi, my name is Tim Alvarez. I'm a PhD student at the Civic AI Lab. My research focuses on deep vision and how we can make deep vision models for prediction responsible and explainable. This is all to help our case subject, which is the city of Amsterdam. See, as a growing city, Amsterdam has many different vibrant neighborhoods. These different neighborhoods all have their own characteristics. These can be socio-economic, environmental, or health-related. The Dutch Central Agency for Statistics and the Research, Information and Statistics Department of the Municipality of Amsterdam use indicators such as mean income, education level, health deprivation, and crime rate to quantify these neighborhood characteristics. These characteristics are important as they allow us to recognize inequality and to make policy and investments aimed at minimizing inequality in the city. Recently, another type of data has been used to complement these survey-based characteristics and predictive models: panoramic imagery. Over the years, the city of Amsterdam has been covered in panoramas, 360-degree photos that have been taken every couple of meters throughout Amsterdam. With computer vision, in particular deep vision, we can use panoramas to create representations of the city. Using these representations, we can train a model for predicting social, economic, and other inequalities in the city, as has been previously done by Swell in 2019 in the Greater London area. However, artificial intelligence and combating inequality do not necessarily go hand in hand, as artificial intelligence is often a force in creating inequality. When we entrust our model with making the best representations, we're also allowing it to be interpreted in an unethical way. An example of a racist model is easily drawn. Take, for example, a task in which we want to predict what causes poverty by using a computer vision model. In this example, we encounter a neighborhood with a majority of first-generation immigrants. This neighborhood could very likely have a lower than average mean income. A visual model, however, could correlate this mean income with certain visual aspects that are pertinent to a different culture. Therefore, the model would learn to see certain cultural aspects as a potential indicator for poverty. While the prediction can still be correct, it also has a racist undertone. The idea that simply having a different culture could be a predictor for your mean income. To an observer not familiar with the inner machinations of such a model, this could be interpreted in the wrong way. To tackle this, we need our model to be responsible from an ethical perspective. In our case, this means it has to be explainable. Why does our model predict in the way it does? To answer this question, we need to take a look at how an analogous model would work. For such an approach, we would use a deep vision model. Deep vision models are neural networks, large models consisting of multiple layers and thousands, if not millions, of trainable parameters. They allow us to reduce large images to smaller vectors that serve as representations of these larger images. Deep vision allows us to learn what visual aspects are important to keep and what are redundant. While they're good at the task at hand, they're not transparent in the way they choose these visual aspects and subsequently make their predictions. Their sheer size make their decision-making process uninterpretable for humans and are subsequently referred to as black box models. To understand the reasoning of black box models, we have two options: develop ways to interpret what is happening inside the black box, or compare similar situations with the black box to see how it reacts. To interpret what is happening inside the black box, Carter published a paper on activation atlases in 2019. Activation atlases can be seen as a machine-learned alphabet of images, an array of simple atomic concepts that are combined to form complex visual ideas. These allow us to look into deep vision models and give a global, human interpretable overview of concepts within the hidden layers of the network. When is an image considered an orange, and when is it considered a lemon? They can help to show the boundaries of their visual predictions and as such are helpful to the computer vision scientist. Through activation atlases, we can understand how the categorization of an image or the identification of objects come about. However, activation analyses are less useful for lay users of computer vision technologies, such as civil and legal servants. A less complex and more understandable approach uses case-based reasoning. In short, after a query is presented, a case-based reasoning system would retrieve the most similar cases using a technique such as k-nearest neighbors. A complex system could predict the price of a house, and a less complex system could provide similar examples surrounding this prediction to show how the prediction was made. This makes the system, as some claim, to be naturally transparent, as reasoning from example is similar to what human experts would do. Case-based reasoning models can be used in combination with neural networks to be called twin or hybrid models. While these options provide building blocks for more understandable models, the biggest problem might not even be tackled. Are we simply treating the symptoms of a bigger problem? The fact that most artificial intelligence models are not inherently explainable. Computer vision models are still just complex mathematical equations that are often trained for one task and one task only. While a deep vision model might be good in recognizing a house, does it know what a neighborhood is? Our research aims to not only make fair and responsible models, but hopefully also more intelligent models that are more in line with what humans see as intelligence. If we can circumvent the need to explain what is happening after the fact, we can allow an AI's thought process to be understood by everyone. That way, we can build a fair and responsible future.